to solve another Leetcode problem 919, complete binary tree inserter. So normally, if we were to insert a node into a binary tree, it's going to be a difficult problem. But for this problem, it is just a complete binary tree. So this means from the beginning, the complete binary tree is prepared for us. So it is a binary tree in which every level except possibly the last is completely filled, and all nodes are as far left as possible. Yeah, so definitely if you already know the complete binary tree, you don't need to check that because it's exactly the same. So for example, 1, 2 is a complete and 1, 2, 3 is also complete. If we were to insert another node 4, so 1, 2, 3, the 4 should be at the left side, but there's no node we can hold at the left side, so we're gonna go to the next level. So it's gonna be the left child of node 2, so it's gonna be this node 4. Yeah, so we can solve this problem directly by using the level order traversal. So we're gonna check all the nodes. So if a node, for example, this is a node 1. Yeah, so this is a node 1. If a node, if it has a left child but it has no right child, so we're gonna insert it to the right child. Yeah, now we have 1, 2, 3. So we're gonna check one by one. If we find one node which has no left child and no right child, it means this is gonna be a leaf. If we find the first leaf, so we're gonna insert it. So we're gonna insert this node 4 at the left side, and we're gonna stop it immediately. So this is just the basic idea. Now let's just try to solve it. I'm going to prepare a self.root. It's going to be equal to the root. Yeah, and from here, because we need to return the self.root, now we just need to check the insert. Yeah, so let's prepare a queue. It's going to be the queue, and inside it's going to be a self.root. Yeah, let me just check how many nodes. At least we're going to have one node. It means we don't need to check. Yeah, otherwise we have to insert the node as the root, but we already have a root, so we just need to prepare a queue, and then we can check that, and the node gonna be equal to q.pop left. So if node dot left, so the queue needed to append node dot left. So if node dot right, so queue needed to append node dot right. So this is just the basic pattern of BFS. Now we need to check if it's gonna be a leaf node or it's gonna only have a left child but there's no right child, and we need just to have a check. Yeah. So if not node dot left, because we don't need to check the node dot right, because if there's no left, definitely there's no right. Yeah. If no left child, so what are we gonna do? So node dot left is gonna equal to the tree node, and with the value, and we can break it immediately because we don't need to do anything. And another check is if not node dot right, it means it has a left. So node dot right is gonna equal to tree node with this value, and we can break it immediately. Yeah. So this is gonna be the entire code. Now let me yeah, because we need to return a value for this insert, we need to return the value of the parent. So we need to return the parent's value. So what is the parent? So the parent is going to be node.value. Yeah. So for example, from here, we're going to break it. So node.left is going to equal to a tree node. But we need to return the node.value, because from here we break it immediately. Now we have this node, and similarly for the right side, so we're going to directly return node.value. Now let me just run it to check. So as you can see, it works. Now let me submit it to prove it can pass all testing cases. As you can see, it passed all testing cases. Yeah, I think this is going to be a good problem, because this is a complete binary tree. It is not that difficult. Yeah. We just need to check the leaf node or the left child or the right child. We can check it directly by using the level order traversal, or we can use it by using the BFS to solve the problem. So thank you for watching. See you next time.